So last time we talked about taking vectors, two of them that add together, that would give us this resultant vector. So like we'd go over this far, and then we'd go up. Today what we want to do is flip the script. Here I already have a vector, it's 40 degrees. And it goes at 40 degrees north of west, and it goes for 14 something, meters, miles. Let's call it miles for right now. What I need to be able to do more complicated addition problems is break this into its components. What two vectors would add up to this single vector? Well, how far in the x direction would I need to go? And then how far in the y? We do this by using, again, our trigonometry and tricks. So let's go ahead and take a look at how this goes. We need to break this up into two vectors. So let's start with x comes earlier in the alphabet. We have a right triangle once again because we're just splitting it up into vectors. So in this case, x is the side adjacent to my angle, and 14 miles is my hypotenuse. If I go back to SOHCAHTOA, adjacent and hypotenuse is going to be cosine. Whereas if I plug in my numbers, x over 14 miles equals cosine of 40. Rearrange it, x equals 14 cosine of 40. At which point you just need to go get your calculator. So 14 times cosine of 40, make sure you're in degrees, is 10.73 miles. Awesome. What about y? Well, it's just another side of the triangle. In this case, it is the side opposite our angle, and we have our hypotenuse. So opposite over hypotenuse, think back is sine of an angle. So just plug in. Y is opposite. H is hypotenuse, or in this case, 14. And then sine of 40. Quick note on symbols, because it will inevitably screw someone up. A circle with a line going this way is theta. Use it for angles. A circle without a line is the letter O. And a circle with a line going at a slash, like this, contained by the circle, is 0. I do this so I can tell them apart, because otherwise I wouldn't be able to tell this away from this, just so we don't get anyone confused. Regardless, you plug that in, we get y equals 14 sine 40. Plug it in, get our values, and we'll get 9.0 miles.
Now, strictly speaking, I made an error here. This should be 10.73 west and 9.0 north. I didn't say that because it's implied, at least commonly so. With that said, make sure when you are doing vectors and breaking into components, you are giving directions.
To make this really work, we got to look at some other fringe cases, we got to look at some other cases. So let's give this another go. A way this is typically done is you will be given an angle, such as 35 degrees west of south, and then you'll need to draw it in. So you get your coordinate grid, and then you draw. Well, west of south, so go south and then go west 35 degrees, puts you here-ish. That is your angle. Well, we also need to know how long this is. So you'll get 15 meters at. Now, whenever you do this, there are two ways you can break it down. You can either go, this is 35. I need to make a triangle that includes that 35. At which point you trace this over this way towards the y-axis. Let me do that in red so you can see it. And then this would be your triangle, with this being y and this being x. Why is this y? Because it goes up, down. Why is this x? Because it goes left, right. Alternatively, and this works just as well, you can go, well, this is a 35-degree angle, which means that this one has to be a 55-degree angle, and then you can always trace to the x-axis. Either way will give you your answer. The main benefit to doing it this way and always tracing to the x-axis is your x will always be cosine and your y will always be sine. If you trace to whatever axis is nearby, that might switch every so often. I personally will trace to the nearest axis because I can do sine and cosine like that. But if you have trouble with them and remembering which one goes where, I suggest tracing always to the x-axis. Either way, you can break this down and find these values. I said that this is 15. Find your y, find your x. It'll be the same either way you do it, but go ahead and give it a try on your own. Okay, if you went through and did all your math carefully, you should get the y is 12.29 meters. I did y over 15 equals cosine 35. And you should get the x equals 8.60 meters. I did x over 15 equals sine 35. I went to the y-axis. If you happen to go to the x-axis and use the 55 instead, that's okay. You'll get the same numbers either way. I did it over here in blue just to verify that. But you always will get the same number. Just got to be careful where you put those sines and cosines.
Again, here I've made a mistake. Even though it's not on the board, that 12.29 meters in the y direction should be south, and that 8.60 meters in the x direction should be west.
This is how you break down vectors. In the next vector video, we'll talk about how to add vectors that aren't at right angles to each other using this and what we learned previously.